Crossley and physics students around the world. Einstein here to discuss the physics of tennis. I'm here today with my partner, Glozell, who is currently at the lab site. To the lab!
Thank you, Einstein. Glozell here, Einstein's sidekick, with the science of tennis. Now, follow me as we go to the lab. Today we've constructed a magnificent miniature tennis court for y'all's amusement, and also to show you the physics of tennis. The following physics concepts that will be discussed in this video are...
Who let the dogs out? Who let the dogs out?
Tension. The word tension is commonly used to mean the tendency of the rope to be pulled apart. Oh, Einstein, I didn't see you there.
Tell us, Glozell, how does tension have anything to do with tennis?
Well, when the strings are strung on a racket, they can either be strung with high tension or low tension. In other words, tightly or loosely. When the racket comes in contact with the ball, the strings give a little in the opposite direction, giving the ball its momentum. The lower the string tension, the more the strings give, resulting in a faster projection of the ball off of the strings. And vice versa, the higher the string tension, the less the strings give, resulting in a slower projection of the ball off the racket, but more control. These differing effects are due to the ball inelastically colliding with the racket. Oh no, here comes an inelastic collision! A topspin shot is hit by sliding the racket up and over the ball as it is struck. By dragging the racket over the ball, the friction between the racket strings and the ball is used to make the ball spin forward towards the opponent. The shot dips down after impact and also bounces at an angle lower to the ground than a shot hit with no topspin. As the ball travels towards a player after bouncing, it has natural topspin that is caused by the friction of the tennis court. When hitting a topspin shot, the player is reversing the spin of the ball, which requires more energy.
Peace up, A-Town down. Yeah.
Newton's laws! Newton's 3 laws are essential to the game of tennis.
Newton's first law states,
A body in motion tends to remain in motion, and a body at rest tends to remain at rest.
Newton's second law states,
Force equals mass times acceleration. When the racket comes in contact with the ball, the racket exerts a force on the ball, propelling the ball forward.
Newton's third law states,
Every action has an equal and opposite reaction. The ball coming towards the strings bounces off and goes over the net, which is equal and opposite.
Impulse momentum theorem. The impulse momentum theorem states that when a net force acts on an object, the impulse of the force is equal to the change in momentum of the object. We must remember that in tennis, the swing of the stroke is in a negative direction compared to the speed of the ball. If we know the initial velocity of the ball, the time of the point of contact between the strings and the ball, and the final velocity of the ball, we can determine the impulse. The impulse is the time of the point of contact between the strings and the ball multiplied by the force of my swing. Rotational momentum.
Einstein? Einstein, where are you?
According to my studies, the rotational momentum is what makes the topspin the most deadly. While in its trajectory, topspin shots rotate the ball. Therefore, the ball's rotation gives it an extra velocity vector called the angular velocity. Angular velocity plus linear velocity equals the speed of the ball. There are 2 ways to find angular velocity. The first way is to divide the linear speed by the ball's radius. The second way is to divide the number of rotations of the ball by the total time in motion.
Kinematics. When hitting a topspin shot, the racket is not perfectly parallel to the path of the ball. Instead, the stroke has 2 components, the horizontal and the vertical. The force in the x direction is equal to the total force times the cosine of theta. The force in the y direction is equal to the total force times the sine of theta. Just a little side note for your amusement. This is the dead spot. This is the vibration node, aka sweet spot, and this is the bouncing location. Can you guess which spot on the racket JP hits the ball?
The dead spot.
Hey, hey, teach me how to do it, hey.
Thank you for tuning in.
See you next time on Einstein the Science Guy. Einstein the Science Guy.
Glozell, Glozell, Glozell.
Einstein the Science Guy. Einstein. Jenny Edwards.
Einstein's sidekick, Glozell.
On my way,
Jordan Joe.
on my way.